I brought the two NECs back. Guys, I'll try to get you. I'll try to get us all the way through the Lovins text. Does that sound like a reasonable goal by the end of next week? So.
I don't know if I can get all the way through it. I'll try.
Yeah. Well, I think what I'll try to do is.
There's only 2 or 3 chapters left.
There's not that many chapters. It's very dense, though. It's part of the issue. Maybe what I'll try to do, just to make it a little less painful, is in the question I'll sort of say what chapter, maybe what figure, and you know.
Sure.
'Cause that's normally I just kind of like flip through. I'm like, oh, that looks interesting, relevant.
I understand that totally.
Yeah.
Taking the test.
Yeah.
The first test, it was like, he just flipped through this. He just flipped through this.
Yeah.
I was like, did he even read this thing? I was like.
Well, I mean, I have read. I mean,
Speaking
I've
of
got
Lovins,
some major notes in here.
I'm
I've read.
kind of off the subject, but
Yeah.
I'd like to go over the last test.
Sure.
real quick.
Yeah.
Real quick,
Let's do that first.
Just to get it out of the way.
Yeah, let's do that
And
first.
So,
and we'll do
have
it.
you entered grades for the practicum yet?
Oh, God, no. I don't think they're due yet, but I should.
Well, I would like to go over that practicum, just sit down and go over it with you sometime before.
Yeah, I have office hours tomorrow. Do it then.
That'll work for me.
Okay. State in progress. Oh, this one's just a decimal point. I thought that might be a turd. How many millions of barrels of oil were burned per day in 2010 in non-transportation? So transportation is chapter 2. See if I can find that.
Do you know how much we produce in the U.S. per day?
Like from our refineries
Yeah, or like
in barrels?
Bakken related.
I don't off the top of my head. I think it's, I mean, we could probably use this number, as I think,
I think it's like 8 or something, isn't it? Or less.
8 million barrels per day. I think the EIA website would know. I mean, that sounds like, well, how many millions of barrels of oil were burned per day? So if we look, I think this is figure 2.2. And this was confusing to me too, so I might have even written this wrong. But
I got it right out of the book, it was words.
Oh, did you?
How many millions of barrels were burned per day in 2010?
I'm glad we're looking at this.
2.2?
Well, I'm looking at figure 2.2. If you can find it written somewhere, let's use that, because I'm having a little. Oh wait, here we go. Hang on. It says 13 million barrels of oil, roughly $1 billion worth, that keep America moving each day are mostly wasted. Well, right there, he says 13 million barrels per day. Now, when I look at figure 2.2, I'm really glad we're looking at this, because
What's million barrels, what's the BL?
well, when I would have looked up MBBL, I read that as 1,000 barrels, but maybe it is a million, or maybe,
I think 13 is just transportation.
yes, I think that's right. Because if you look at figure 2.2, autos, trucks, and other is the transportation. So, let's look at this. So a barrel is a unit of volume. And then if we go down here, U.S. dry barrel. So this, look at this. So MBBL, 1,000 barrels. So that's a typo on figure 2 too. Because MMBBL is 1,000,000 barrels. Now, let's see which one is correct. Because see that?
Yeah.
I was a little thrown off by that too. Let's see how much energy is in a barrel of oil. Barrel of oil, it's actually a unit of energy. Well, barrel of oil equivalent is a unit of energy based on the energy released. 5.8 times 10 to the 6th BTUs. Let's pop that in. Energy per barrel equals 5.6 E6. Is that right? And that's in BTUs. BTUs. Oops. BYU. BTU. And then what's how do we get from BTUs to joules? Is it 1,055?
I have to Google it.
I do too. Joules per BTU. Yeah, 1055. So equals that number times 1055 joules. Okay, so that's how many joules per day, and then is that that's just the United States and just transportation. Okay, so this is per day in transportation. Now let's take the population, 300 million.
So the whole world only used 17,000 barrels of oil in 2010?
No.
Well, that's what that says, doesn't it? The question?
Yeah, it is, and that's so I'm glad we're looking at it because there's a typo in the figure.
That makes no sense.
I know.
Does the capital M mean anything as opposed to a little m?
No, it doesn't. There's no little. Yeah, so that was a little confusing for me. Wait. Now I'm even more confused because the text says 13 million barrels per day, and figure 2.2 says per year. Or is figure 2.2 the daily average in 2010?
Well, it does say /D, MBBL/D.
Per day, okay, thank you, perfect, okay, good. So that is per day. Good. All right, now, so 300 million people, so this is gonna be people, and this is gonna be joules per person per day, transportation, equals joules divided by people. Equals joules divided by people. Weird. Hang on, maybe that's wrong. Equals 300 E6. Now this is even weirder. Oh, wait. This is BTUs per barrel, right? Yeah, BTUs per barrel. Okay, here we go. This is getting better. See, if you don't do this stuff regularly, and my brain apparently is on summer vacation too, you start to lose it. Okay, BTUs per barrel, now this is going to be barrels per day right here. And yeah, so I'm looking for 17. So this is 17E6, 17 million, right? Equals 17E6. Okay, BTUs per barrel. Okay, now what I'm missing is this line. Insert, and this is BTUs per day.
17 million multiplied by 365. You're using 17 million a day.
Yeah, but I'm
70,000.
just converting it to joules. Yeah. So 17 million barrels times that many BTUs per barrel. So it's that many BTUs per day. This equals that number times 1055. There's your 300 million people. Okay, there's a number. That's more like it. 19 joules, yes, we're using. Okay, so this is much more like it. Equals this number divided by 1E6. So this is going to be megajoules per person per day oil. It's not just transportation. Okay, now, guys, does that seem like a lot or not very much? Knowing that you know from NRG 101.
Definitely seems like a lot to me.
But it's not, though, because if you remember from NRG 101, we use 10 megajoules metabolically. We use 200 technologically, globally as a species per person. And North Americans use 1,200 megajoules per day. Are you with me on that one there,
I guess
Orla?
it's the word, yeah, the word, how you're comparing it there.
Yeah. So this equals equals 335 divided by 1,200. It's about where you'd expect. It's 28% of your energy consumption is transportation.
Energy.
So it's right on. Are you with me on that one there, Gary?
Yeah.
Is that number, I mean, are the numbers when I say 10 megajoules and 200 megajoules, is that ringing any bells?
Yeah.
Okay. So, nevertheless, to go back here,
The 10 megajoules comes out of my own equations for the stuff I did in DC and Portland.
oh, yeah.
Because I actually did that stuff on paper.
Oh, sweet.
So I remember that, and when you did the energy,
When you know I sat down,
we never sat down and did that. That was just more, you read it in a book and then you're done with it. You
Well-
never had any equations out for that.
yeah, we did in the Commons, in the cafeteria that one day, we sat down and came up to our 15 acres or 15 square miles.
That wasn't for the class though. See, I'm saying, for me, it was easier when I wrote it down and remembered.
Oh, yeah, I'm with you. So I think this is actually, I think this is right. What you put down here is 17, and my .7 was wrong, so I'm glad we looked at that. Did you miss that one too?
I don't know, because I don't think we can review.
I don't know, I was happy with this test when I got done. I was actually really happy.
Yeah, no, that's good. What's the other one here? What is the delivered energy intensity in 1,000 BTUs per square foot per year of existing buildings in the US. Oh, you might have just looked at it, read it a different way, yeah.
I'm gonna take it a while to find this one.
Is it not in,
Oh, it's in here, it was just hard to find.
No, it's in a,
it's in chapter 2, isn't it?
quadrillion BTUs.
Oh, it's in,
Is it in chapter 3?
yeah.
Did I sneak a chapter 3 in there? It is in buildings, well, obviously it's in buildings.
Okay, so it's delivered, US, what is the delivered energy intensity? So you've got 11 and 9 quadrillion BTU, but that's in thousands, K BTU, instead of Q.
Oh,
So I put it in thousands and added the 12 zeros. Did I format that right? Is that 20,000 quadrillion BTU?
that's, you've got 2,000 trillion. You've got 2 quadrillion there.
Okay, oh, it's only 2 quadrillion? Oh, I need another zero, don't I?
Where are you getting your number?
There and there.
What page is that?
Okay, yeah.
So that's 20, and I just needed,
Yeah, that's the total. So the question is asking though, in 1,000 BTUs per square foot per year. And I think, what page are you looking at there?
I'm looking at 84,
Oh, yeah.
and I didn't know what the square foot was.
That's the
I knew
total.
what the year one was, but I didn't know what the square foot was. I
Okay.
still missed it.
Okay.
I mean, I give it a good try, but
Okay.
I'm only quadrillion off,
Well,
a billion off, I guess.
I'm looking at page 79, and so building sector terminology says the energy intensity, and this is the very last paragraph, of a U.S. building is typically stated in delivered energy used per square foot per year, and it's typically in thousands of BTUs per square foot per year. And
Doesn't ask for average, but it's still.
the U.S. average commercial was 90. I think I saw it somewhere else too.
That's a energy efficiency, right?
Yeah. Mm-hmm.
Thing.
Yep.
Okay.
I don't know how I got, oh, and here we go. Table 3-2 on page 108. Benchmarking a new U.S. office building. So right now, so delivered energy intensity is the very top line, and the units are thousands of BTUs per square foot, and the existing is 90. So I guess it's in 2 places.
Yeah, that's right.
Okay. What's the name for the strategy that starts by asking whether there are smarter ways to design the whole building and its interactive system together? I call it integrative design. Yeah, I'm not really sure I really like the way that these questions are getting. It's like the annoying ones I remember having in high school.
how to move
Yeah.
beyond common,
beyond conventional design.
but the right sizing.
Yeah, where'd you see that?
Sizing's on the next page.
Whether outside the building or inside, integrative design has many powerful consequences. One of the most common and valuable being able to shrink or even eliminate mechanical equipment.
Okay, see, that's where I was flip-flopping integrated design, right sizing.
Yeah, I can give you some credit for that. I love it, yeah, he says, that's what I was able to do with my own 4,000 square foot house in the Rocky Mountains. The house is super insulated and 99% passively heated despite temperatures down to -47. Thanks to super windows that look like they are 2 sheets of glass but insulate like 16 or 22. He even says, these measures reduced the house construction cost because eliminating the heating system. The man has no furnace in his house.
In the mountains in Colorado.
Yeah,
For
and-
sure.
I was thinking right sizing would be smarter ways to design a house. You know, you're gonna put a huge air conditioner in the house that doesn't need it,
It's true,
or a huge furnace in the house that doesn't need it.
yeah. Now, if we look, like a 4,000 square foot home is not small. That's twice the size of my house. But here's the part of it. If it were smaller, he would have to have a heater, because the thing is, he's got so much stinking air and just mass, solid mass in there, that the building itself won't change temperature that quickly. I think he's able to ride out these low snaps because there's thermal energy in the building.
Just radiating into the.
Yeah, radiating back. So I'll give you some points for right sizing. I'll give
We
you.
need 10 of these. Wonder how many we're gonna need for lithium.
Probably fewer lithiums, right?
Well, lithiums are pumping more per cell. And you're a lot smaller. The 18 volt here, my newer lithiums are half this size. They're down into here. So they're smaller, lighter, and more compact.
Hey, so Al, I'll give you credit for 17 there. That's correct.
Okay.
It was me putting too much faith in the typo in the figure.
Okay.
And until I did this little Excel thing, I wouldn't have. I'm glad we checked.
I think that was mine, wasn't
I just did Adams too. I just finished yours. Okay, guys, let's
So the next test will be chapter,
yeah, I guess I snuck a few chapter 3s in there on you, didn't I? It goes through chapter 6, so there's, I don't know, maybe I'll just do chapter 3 and 4 this weekend, and 5 and 6 next weekend, and call it good. All right, so let's put a fork in the noodle here.